Hello, welcome to our session. My name is Nancy Lee Wood. I'm with Jim Laurie and Jan Lambert today. We're going to be focusing on Earth's water cycle and the dehydration of the planet, how it has happened, and the kinds of things that we need to be doing to reestablish water across continents. Let me do a screen share. And it's not there now. Oh, Jesus.
You don't have that window to choose now?
I don't have that window to choose. It went away.
So bring it up on your screen, on your desktop, and then it should be the next time you ask to share. So.
Okay.
You got the names right though. That was good.
Hey, old dog, new tricks. It's tough. Woof woof. Plus, I'm a Luddite. What do you want?
Yeah. There you go.
Okay. Hello. Thank you for coming to our session. My name is Nancy Lee Wood. Today, I'm with Jim Laurie and Jan Lambert. We're going to be talking about the rehydration of terrain on the planet. We are losing a great deal of water and we need to rehydrate the planet. I will go to a screen share and this is what increasingly land across continents is beginning to look like. We are in a situation where we have not focused on nature-based solutions. We've been very focused on reducing carbon emissions, but we have not been focused on carbon sequestration. And we need to do that in order to rehydrate the planet. Little to no attention has been paid to this, and especially the photosynthetic processes that are necessary for rehydration. There is a continuing decrease in the amount of water available to the terrestrial portions of Earth, resulting in increased droughts, which of course are preludes to wildfires, encroaching desertification, depleting aquifers, lowered recharge rates of vital water sources. Our lakes, rivers, and streams are not being recharged in the way that they need to be. And we see a loss of biodiversity. And this has been caused by degenerative land management processes. Now, deforestation has been one of the major issues facing us. And deforestation has taken place in large part for agriculture and ranching. We have a population today of 7.5 billion people. It's anticipated by the middle of the century we'll have approximately 9.5 billion, and by the end of the century, approximately 11 billion people. These people need to be fed. And of course, what has taken place is massive destruction of forests in order to do agriculture and ranching. We, in fact, have lost 3 trillion trees over time. A second problem is industrial agriculture, where we see that petrol-based fertilizers and biocides are killing the organic matter in the soil, turning it into desert, turning it into dust, really only being a platform to hold, soil being the platform to hold plants rather than to really provide nutrients into the plants. We also see overgrazing, vegetation having no time to recover and leaving the soil exposed to dehydration. And of course, with an increased global population, human population, we see overpaving taking place for urbanization and transportation systems. The result is the loss of vital photosynthetic activity that nourishes soil life. The reduction in precipitation activity is a result. And of course, Jan's talk is going to focus on a solution to this. The loss of vital biodiversity in animals, plants, insects, and microbes, Jim Laurie will be talking about. And the basic problem is that we are losing water on land, which means less potable water for human use, drinking, cooking, bathing, cleaning, gardening, for agriculture and animals, and also for manufacturing processes. The bottom line is we need to rehydrate the planet. Unfortunately, Jan Lambert is not able to be with us today, and so she has asked me to present what she has to say about small water cycles. The vegetated area pictured here is an example of an urban rain garden, specifically designed to infiltrate storm water into the land. This is being done in many areas to reduce pollution and flooding in nearby streams. But I wish to show that measures such as rain gardens can be thought of as nature-based ways to help combat climate change and not merely to adapt to it. One way to comprehend climate change in a practical way is to state it as being manifested as an increased drought, flooding, heat, waves, and severe storms. Michael Kravchuk, a Slovakian hydrologist, has demonstrated a new angle to understanding and restoring climate through paying attention to water cycles, which he and several colleagues have presented in a publication titled Water for the Recovery of the Climate, a New Water Paradigm. The new water paradigm is based on a fundamental relationship between water and climate, focusing on disrupted natural water cycles as a major factor in increasing global climate change. A standard definition of a water cycle includes, quote, the cycle of processes by which water circulates between the Earth's oceans, atmosphere, and land, close quote. The standard definition implies that there is one water cycle based primarily on moisture from the ocean. This is described in the new water paradigm as the large water cycle. The new water paradigm, however, goes to a step further by describing the small water cycle, the cycle of precipitation which circulates through land and vegetation back into water vapor and then clouds to later fall again as precipitation on land. The distinction is vital because paving, bare cropland, and forest clearing have caused rainfall and snowmelt to be rapidly drained from all continents instead of being recirculated through plants into the atmosphere. When the sun strikes unvegetated surfaces, we can feel heat. The sensible heat will be the result of that. But when the same sunshine reaches a forest, the trees absorb the sun's rays and the solar energy is used to evaporate water through transpiration. Through transpiration, the solar energy is absorbed by water vapor and converted to latent heat with no increase in temperature. Plants, particularly trees, perform a large cooling and moderating role in the small water cycle. The vapor transpired by trees stores solar energy as latent heat. The energy is later released in colder locations due to condensation of the vapor. Thus, temperature differences are moderated in time and space. Increases of sensible heat can contribute directly to heat waves and to fluctuations in air temperatures leading to strong winds. Chronic dehydration of landscapes leads to drought, and rapid draining of stormwater into streams causes floods. These are the consequences of disrupting small water cycles, which are vital to governing local climates on the continents. Instead of contributing to global warming solely to build up of greenhouse gases, we should be paying closer attention to the cycles of water over our regions. All regions must have healthy small water cycles to keep local climates hydrated and moderated. Water needs to circulate, not just in the visible rainfall, snow cover, and surface waters, but where it is out of sight, as vapor, groundwater, and through the plants. Keeping in mind that all water needs to cycle through local and regional ecosystems, we can take steps to ensure that we do not hinder the small water cycle. The key is to encourage rainwater to infiltrate back into vegetated land areas, while avoiding channeling stormwater directly to streams and oceans. Agricultural fields need to be cover cropped, and soil erosion must be curbed everywhere. The good news is that measures being taken in many areas to cut erosion and increase soil infiltration, which are being done to address water solution or pollution and soil loss, but likely also contribute to local and regional climate moderation, if done on a large scale. We now will turn to Jim Laurie and his presentation. Jim?
I'm going to talk about how living things can enhance the small water cycle. There were three processes of the small water cycle that Jan Lambert has brought to our attention. That's infiltration, transpiration, and condensation. Water's biodiversity can enhance and greatly increase the potential of all three of these processes. In the American West, much of the land is now bare ground and has a hard crust. When it rains, there's little infiltration and the flash flooding scours deep canyons in the stream beds. A few days later, the sediment-laden muddy water is far downstream. We have a flood and drought cycle, and the days are very hot much of the year because of this unwanted sensible heat. This is an area that once supported vast grazing herds of buffalo, pronghorn antelope, and elk, as well as 100 million beaver and billions of prairie dogs. Much of this land was covered by perennial grasses and forbs, which fed moist soils 10 feet deep in roots and thirsty mycorrhizal fungi networks. Infiltration was strong, and transpiration through these plants cooled the ground surface. How could this biodiverse, healthier land return? The picture here was taken by John Griggs, who's manager of the Maggie Creek Ranch near Elko, Nevada. It's an area that receives less than 10 inches of rainfall per year. Much of it is winter snowpack upstream in the mountains. After years of holistic grazing practices on the ranch, Griggs was happy about the increased deep-rooted grasses and forbs in many areas. These plants covered bare ground and increased water infiltration when it did rain. As more cattle were added to the herds, and the herds were moved frequently, the animal impact improved infiltration in several more ways. Grazing animal hooves cut into and break up any soil hardcap, allowing for more infiltration and less runoff. Consuming grass makes good meat, but it also makes a lot of dung and urine. In a healthy grassland, the nitrogen-rich urine feeds the plants. Vast herds of dung beetles break up the cow patties and bury thousands of dung balls rolled into each patty. It's also complete with a dung beetle egg, so baby dung beetles start their lives in these little balls. Soil nematodes, earthworms, insects, and microbes benefit from this influx of nutrients pre-processed by the cow's digestion. Nematodes consume from the dung buffet and exude slow nitrogen into the soil for the plant roots and fungi networks. Because of this increased infiltration on Maggie Creek, it raised the flow of the creek during the dry season. The water was clear because it was percolating from below, and there was often flow in the creek for many months. In 2003, beaver showed up in Maggie Creek and in nearby Susie Creek. John Griggs was concerned. Could these critters cause problems on land where he had worked so hard to improve the water cycle? Carol Evans, who was a BLM fish biologist who had been helping the ranchers restore these lands for decades, suggested that they wait and see what happened. The result was that these beaver, whose origin was unknown, began with mud to slow the creek down. Many small dams were created over a dozen miles along the several creeks, and the water tables rose by as much as 2 feet. The reason for the beavers' determination to create deep channels in these creeks through the entire year is to protect their lodges and their young ones. It meant a lot to Griggs when these streams stayed full during the drought years from 2012 and 2015. He didn't have to haul water for his cattle in those years, while his neighbors had a much rougher time. As the beaver activity continues, there are more water-loving trees in the streams. The cattle have water in the area, and it's possible to graze higher on the slopes of the sagebrush, hopefully to bring more perennial grasses and to cover more bare ground. Carol Evans is happy to find more birds, deer, and especially local fish species in these streams. She also observes more frequent rainfall on some of Nevada's mountain ranges. Could the increased transpiration lead to more condensation and rainfall as more ground is covered and the water tables rise in more places? Susie Creek, after more than a decade of beaver activity, has accumulated 2 feet plus of carbon-rich black sediments. I estimate these sediments contain over 100 tons of newly deposited carbon per acre in 12 years' time. That's 8 tons per acre of pure carbon every year. This is an estimate for sure, but it's the kind of process we should be studying in detail. The hope is to rehydrate Nevada and create more biodiverse and water-rich Great Basin. Nevada is the driest state in the nation. If it is possible to do this in Nevada, it can be done anywhere in the continent. By restoring biodiversity globally with a similar focus on the process of infiltration, transpiration, and condensation, we can rehydrate the world. So let's do it. A great book to read about all this was written by Ben Goldfarb a few years back called Eager, Beavers Matter. Thank you.
Thank you, Jim. And thank you very much for joining our session. Just a reminder that the decade from 2021 through 2030 has been designated by the United Nations as the decade for ecological restoration. We must go beyond talking about carbon reduction and think about carbon sequestration. We must regreen the planet. Thank you.